Welcome. Today, we're diving into a technology that has totally flipped the script on how we make, well, pretty much everything. This is the story of next-gen manufacturing, a real revolution that takes ideas from a computer screen and puts them in your hand almost in the blink of an eye. All right, so here's our roadmap. First, we're going to talk about the crazy pressure of the modern product race. Then, we'll get into the big solution. What exactly is rapid prototyping? We'll climb what's called the prototyping ladder, step by step. After that, we'll peek under the hood at how additive manufacturing works its magic. And finally, we'll see how this all leads to a massive shakeup on the factory floor itself. You know, in today's world, it is a flat-out race. It's not enough to have the best idea anymore. You have to get that idea into your customers' hands first. The pressure to just go faster and faster is absolutely immense. And here's where it gets really serious. This number from McKinsey, it's a gut punch. Just a 6-month delay getting a product out the door can wipe out a third of its potential profit. A third! I mean, that's the kind of statistic that gives executives nightmares. And it's exactly why this need for speed is so desperate. So to even survive in that race, companies are juggling 3 huge things at once. First, they have to control their costs. And get this, a mind-blowing 80% of a product's final cost is already baked in during the first few days of the design phase. Second, quality has to be top-notch. Finding a mistake late in the game is a financial disaster compared to catching it early. And third, of course, is time. You just have to shrink that development window. So that leads us to the million-dollar question, right? How in the world do you go fast, stay on budget, and make a great product all at the same time? The old ways of doing things just weren't cutting it. The answer had to be a totally new way of thinking. And that answer is rapid prototyping. This isn't just some new gadget. It's a whole new philosophy for creating things. It's specifically designed to solve that impossible puzzle of speed, cost, and quality. So what is it really? Well, at its heart, rapid prototyping is about one simple, powerful idea: taking a digital file on your computer and quickly turning it into a real physical object you can actually hold. This lets engineers and designers see, feel, and test their ideas right away, catching problems when they're still easy and cheap to fix. The number one benefit is, without a doubt, time. I mean, we're talking about making a physical model in a matter of hours, instead of the weeks or months it used to take. Teams can now iterate on a design, test it, tweak it, test it again, dozens of times in the same period it once took to make a single version. Then there's the money. Traditionally, if you wanted one prototype, you had to create these insanely expensive custom molds or tools. Rapid prototyping just skips that whole step. You can make a single part for cheap, which completely changes the game. It encourages you to experiment, to try wild ideas, because you're not betting the entire budget on one shot. And this is where it starts to feel like science fiction. Because these machines build things up layer by tiny layer, they can create shapes that are literally impossible to make any other way. Think complex internal channels or intricate honeycomb structures. It just unlocks a whole new level of design freedom. All of this makes a powerful strategy called concurrent engineering possible. So instead of the old way, like a relay race where designers finish, then hand it off to engineers, who then hand it off to the factory, now everybody is in the huddle from day one. Marketing, design, manufacturing, everyone. And that physical prototype, it becomes the shared language they all use to give feedback at the same time. Okay, so let's get practical. How does an idea actually go from a sketch to something ready for the production line? Well, you climb the prototyping ladder. It's a journey, step by step. The basic workflow is actually pretty elegant. First, you design your part in 3D using what's called CAD software. Then, you save that design as a special file type, in STL, which is kind of the universal language for these machines. Next, a piece of software digitally slices your 3D model into hundreds or even thousands of super thin horizontal layers. And finally, the machine reads those slices and builds your object, one layer at a time from the bottom up. So where does that initial digital file come from? Well, there are basically 2 ways to go. The classic route is you start with a blank screen and design something totally new. But what if you want to improve something that already exists? Or you need to make a replacement part? That's where reverse engineering comes in. You use a 3D scanner to digitally capture the shape of a real-world object, turning it back into a digital model that you can then modify.
And this is a great look at the different stages. You see, you don't just make one prototype, you climb this ladder. You might start with a really cheap conceptual model just to see how it looks and feels. Then, a geometric prototype to make sure all the parts fit together perfectly. After that, a functional prototype to see if it actually works. Then, you move up to a technological prototype using stronger materials for real stress tests. And finally, you do a small pre-series run to get the actual factory line dialed in. Each rung on that ladder reduces risk and gets you closer to a perfect product. So, we've been saying building layer by layer, but how? What's the magic going on inside the machine? This is the technology at the heart of it all, called additive manufacturing. You've probably heard it called 3D printing. The core idea is simple, but it changes everything. For centuries, we made stuff by subtractive manufacturing. You know, you take a big block of metal or wood, and you cut, drill, and carve away everything that isn't your final part. Additive is the complete opposite. It starts with nothing, and it adds material, layer by layer, only where you need it. And there are three main ways this happens. You can start with a vat of liquid resin and use a laser to trace a layer, hardening it instantly. Or you can take a solid filament of plastic, it kind of looks like weed whacker line, melt it and draw each layer with a tiny nozzle. It's basically a super precise robotic hot glue gun. Or you can spread out a thin layer of fine powder and use a powerful laser to fuse the particles together just where your part needs to be. And hey, this isn't some futuristic tech that's just around the corner. Look at this chart. The data is from 1998. Even way back then, this was already a serious tool for major industries. Consumer goods were the biggest users, but right behind were automotive, computers, aerospace, and even medicine. They were already using this for everything from car parts to custom medical implants. And that brings us to the final piece of the puzzle. And honestly, this might be the biggest game changer of all. What happens when this technology gets so good that you're not just making prototypes anymore, but you're making the tools that make the final products? Welcome to the world of rapid tooling. The idea is to use these super fast additive methods to create the actual molds, dies, and fixtures that are used on a real assembly line. It's the critical bridge connecting the design studio to full-scale manufacturing. And the uses are incredibly powerful. We're talking about 3D printing an injection mold for making thousands of plastic parts, or printing complex sand molds for casting metal engine blocks, or building custom jigs to hold a part in exactly the right spot for a robot on an assembly line. Making these things the traditional way takes months and can cost a fortune. And that right there is the ultimate impact. The incredible speed we saw in prototyping is now bleeding over into actual production. A company can go from a final design on a computer to cranking out thousands of production-quality parts in days, not months. This just fundamentally rewrites the rules of manufacturing. Which leaves us with one last big question. We've gone from a world where making the physical thing was always the slow part to a world where it can almost keep up with the speed of our ideas. So, when manufacturing can move at the speed of thought, what's next? What kind of future does that unlock for everything we design, build, and dream of?